Okay, hello. So let's talk about coding agents. And the way I think about coding agents is that I want them to be able to do what I do with my colleagues. And what I'm able to do with my colleagues that has to some degree the same experience in the project as I do is that I can give them a very ambiguous statement or a prompt that, for example, I want the count to be persisted in a database. When I say that to a colleague of mine working on the same project, they intuitively immediately understand what I'm talking about, and they will have some idea in their head about an outcome that I probably will accept. Like I'll do a code review, maybe I have some input on certain things, but like broadly speaking, it's an acceptable outcome. And how do we actually achieve this kind of interaction with the coding agent? Having these very ambiguous prompts and they still understand what I mean to the extent that they will produce an acceptable outcome, just like a colleague. Well, just like a colleague, they need to retrieve context. And they retrieve this context to narrow down the spectrum of accepted outcomes. So for a colleague, that is basically using the brain, right? They have a lot of experience with the project and they retrieve the necessary context to act on this prompt, basically from their brains. And then they might need to use some tools in real life, like looking at code, searching some documentation on the web, and so on and so on to actually do the implementation. But that's how they do the retrieval. And the goal is to narrow down to an accepted outcome. So if we think about this in the sense of colleagues and agent, it's like if you gave this prompt to a completely new colleague on the team, that person would have like a moderate intuition about how to accomplish this. And what I mean is that they were hired based on the job description. They know that, for example, they're going to work with React and they're going to work with TypeScript, and that maybe you have talked about starting using Firebase that hasn't been implemented yet in the project. So they have like a moderate intuition. But when it comes to the additional retrieval necessary to actually do something with this, that will be very slow, right? Because they haven't looked at the code base before. There's still like open questions on how to do certain things. They need to ask more, they need to search more, they need to retrieve more. But then if you give it to, as I mentioned, a colleague that has somewhat similar experience, their intuition will be very good, right? They have so much brain retrieval capabilities to act on that prompt. And also their retrieval is more efficient because they have more hooks. Like they, instead of like reading a lot of files, they might just go to a specific folder and figure out which file or which function, for example. So they're faster at doing retrieval. But then you have an agent. An agent doesn't have any intuition at all. Like these agents knows about TypeScript. They know about React, at least up to the point of their training data, but they don't know that this is what they're gonna apply based on the prompt because it's way too ambiguous, right? So by default, they don't have any intuition at all. But their capability to do retrieval is incredibly fast. So what I mean to show here is that even though these agents seems to not be capable of contributing to a code base because they just don't understand the project context, that is true, right? By default, that is true. They need to have a retrieval mechanism to build up the necessary context so that you will get like an acceptable outcome from that. So that's what we're gonna show in a demo here to build up our own sense of intuition of how does retrieval actually affect this non-intuitive agent? Like how do we make it seem more intuitive? So let's move into the demo. Oops. There we go. Okay, so we have a project here, and this project has an implementation of an agent, and then it also has this project. And this project is basically a Vite React template, which has just like a counter in it. And it also has, let's see, it also has Firebase as a dependency. Okay. So what we're going to do now is that we're going to ask this agent to act on this prompt. Like, I want the count to be persisted in a database. And we're going to start with a shitty agent, and then we're going to move to a simple agent, and then finally we're going to move to a super agent. And please note right now that this is not about creating an awesome coding agent. This is about building up your own intuition to see how retrieval actually helps the agent seem more intuitive. Like, it's more able to narrow down an accepted outcome, or narrow down to an accepted outcome. Okay, so this shitty agent, the way this works is that it's given two tools. It has the ability to read files, and it has the ability to write files. And it has a simple set of instructions, which is write the suggested changes to the project, respond with a short summary of the changes without code references. So let's run this now. Let's see. I want the count to be persisted in a database. So let's see what it does. So here we can see immediately that it tried to read a Python file and a database, and it says it pairs that the specified files and database do not exist in the project. So basically, it has absolutely no understanding of what I meant, right? And it might have actually tried to just write a file as well, maybe even in JavaScript. Like, it could do anything, right? It doesn't have any intuition about what we needed to do. And this is what also happens when you ask coding questions to ChatGPT. Like, you ask ChatGPT to generate some code for you. Like, I see very often that people complain about the output of that. But not as often I see people like complain about their own prompt, right? There's a lot of hidden or missing information in that prompt. Like, there's missing context, and ChatGPT isn't able to retrieve any of the hidden context in your prompt because it's in your mind, right? So I think we need to be more fair to ChatGPT, that when we ask it to generate code for us, the problem is our prompt. It isn't ChatGPT, okay? I'm not saying ChatGPT is perfect. Like, it can be better, but I think it's a nice note. So let's move away from our shitty agent and let's move to our simple agent instead. Now, our simple agent has a code rag. And this code rag is built using Llama Index. And the way it works is that when the agent fires up, it goes through all the files in the project, and it actually goes into each file and creates a summary of that file. Because when you have these prompts about implementing new things, you want to conceptually understand the project. You don't care about functions and variables at this point. You just care about what is in this project, where is it, how do I approach implementing this new thing. And so that's what this code rag tool does, is that it creates a summary of each file. But it doesn't only create a summary of each file. It also goes to the parent folder, and it creates a summary of all the files and folders in that folder. So you also have a summary of all the folders. And you might not think about this, but when you are tasked to implement something, your intuition isn't based on functions and variables. It's conceptually the file structure and the meaning of different files and folders. That's kind of the synthesis of what you have in your mind. Maybe you remember some functions and some variables and stuff, but in a broad aspect, it's more conceptual, your understanding, and that's what we're trying to kind of simulate here. So I've not changed the model of this agent or anything. I've just given it the possibility to retrieve conceptual information about this project. And what I've done with instructions now is that I'm telling it specifically. So I'm not expecting the LLM to just understand to use this CodeRag tool. We need to use it for something specific. So you can say that the LLM doesn't have any general reasoning capabilities. What it reasons well on is your instructions. It's not the prompt that it needs to reason on. It's the instructions that's important for its reasoning. So what we do here is that we say that it should first go and query the CodeRag tool in the format of, does this suggest a change, where the change is something it brings in from the prompt, already exists in the code. Like, this is really important. Like, what does this suggested change mean in the context of the code? And then the next instruction is, if the suggested change does not exist and it is a new implementation, query the CodeRag tool in the format of, list the files and directories that would be affected by the following change. So that means how would we, what are relevant files and directories for implementing this change, right? And then we ask it to read those affected files and write suggested changes to the code base like before. So let's start it up again. There you are. Okay, I want the count to be persisted in a database. So let's see now. We're gonna read this after it's done because the scrolling jumps as it's working. So you'll just have to be patient. Let's see. It starts reading some files. And it needs to read these files to understand how to change them, right? So you can't like update a file without knowing the contents of the file. So let's see what it summarized with. The code has been updated to persist the count in a database. Specifically, the source app file was modified to include logic for fetching the count from the database, blah, blah, blah. No changes were necessary for the other files based on the current requirements. But what's more interesting is that when we first asked it about the persist the count in a database, it states that, if it already exists, it states that no, the suggested change to persist the count in the database does not already exist in the code. But it does state that the current implementation of the React component includes a button to increment the count. So it's able to reason about what's in here and what's not in here, and what would generally be needed to approach this. And then we ask it to list the files and directories that will be affected by the change. And then it says the source app TSX file contains the React component that displays the counting, and it would need modification for persistence. Then it says there's a source directory where new files can be added to handle database interactions, blah, blah, blah. It indicates that there's a vite config file because you might need some configurations to support database interactions, and so on and so on. So that's great. But let's look at what it actually implemented here. So it made a change to the app TSX file. Let's see. And what did it actually do? Yeah, so what it did is that it just assumed that there is a database here. That there is a database behind an API. And then it basically goes and fetches that, and then it posts to set that count. Again, like, now it understood where to implement something. It had an understanding of the code base. And again, we didn't change the model of the LLM or anything. It's really important to really put in your mind that it's the exact same LLM. The only thing we're doing is that we're adding retrieval mechanisms to the LLM. So it got better, right? It even wrote it in the correct file, and so on and so on. But now let's do another jump. Let's go in here. Let's stop this. And let's, instead of simple agent, we're now gonna do super agent. And let's look at what we can start it. And then in the meantime, let's go in and see what super agent does. So super agent doesn't only have the code rag tool, it also has the dependency rag tool. And the way the dependency rag tool works is that it goes through the dependencies of the project, and then it finds the type definitions of the dependencies, and it builds usage examples out of that using an LLM. And what's important about using type definitions is because it's very reliable, right? The type definitions, if they are there, they will overwhelmingly likely be correct, because you can't build a dependency if the typings is off from the implementation, right? Because the typing derives from the actual implementation. And it's not minified, so it has a lot of domain specific naming and stuff. So it's good information to create usage examples out of. But still, it isn't documentation, right? So it's not the most ideal thing to produce usage examples from. So the dependency rag also includes the README, because the README typically has some documentation on how to use it. Now, it's a little bit less reliable because it might not have anything there. It might just be a link to a website or something. But it can also be that it's not in sync with the actual implementation. Like someone might publish a version and forget to update the README, right? That happens. And then you can argue, but why don't you just go and scrape the website? Well, the problem is versions, right? The website is typically only the latest version of that dependency. So if that's a perfect match, it's a great resource. It takes longer to learn from a website than using files on the file system, but it's a great source of information, right? But it's completely unreliable compared to the other two sources. So a combination of all three would probably be the best option. But this implementation only takes the type definitions and the actual README of the dependency. And then we add the code tool and the dependency tool, and of course read and write files. And now our instructions are somewhat the same. We still query the code rag tool to figure out if the suggested change already exists. And then we say if the suggested change does not exist and it is a new implementation, we say query the dependency rag tool in the format of write a short general guide on how to implement the change. So what's funny about this is that this dependency rag tool is basically a service to generate articles on how to use a dependency to implement different things. And it's kind of how we work, right? We have a tendency to go to articles and see how do we use this dependency to do whatever, right? But this happens on the fly with an LLM. So now we get like an understanding of how applicable the change is to the code base. We have a guide on how to use the dependencies of the project to do this implementation. So now we can go in and we can figure out where we should implement that, and then actually go and perform the implementation. So let's see how it performs now. I want the count to be persisted in a database. And now this is going to take longer. And I think that also what helps pointing out now is that when we're going to have, at some point, we're going to use these agents to some extent. But I don't think they will be like Copilot, where you have a close interaction and you work with actual code. It will be, they wouldn't only need to be autonomous in having an ambiguous prompt and do an implementation and also validate it, which is a completely different conversation. but they also need to be autonomous on when they go and suggest something. So what I mean is they need triggers, like you manually going and saying, start a new branch with the suggested implementation of whatever. It will take so much time for it to build that it would just feel weird. Like you would just creating a branch is instant, while creating a branch with a suggested implementation will take some time. So it needs triggers to do that autonomously as well. So you can imagine if you could link it to GitHub, you could have bug issues, trigger an agent to go and suggest how to fix it. Or in linear, you could label a ticket to trigger an agent to go and create a branch with a suggested implementation. Like, I think that's the kind of flow we want with these agents. Because then it has a lot of time to do this. And I think it's going to take a long time for us to actually have a reliable agents from end to end, because the validation step is the most tricky part. But this is exactly where us as engineers really fit in now. It's like, okay, go and create a suggestion for me, but then I can either go in and review it, or I just jump into the code and I continue working on it. So let's see, let's read the summary first. So what it did is that it created a Firebase config TypeScript file to initialize Firebase. So now it understood that because the project has Firebase, it just uses Firebase. It added an API to read, write, and increment the count. It updated the source app file to fetch the initial count. And it says that these changes enable the application to persist. So what's new here now is that it still says, like when I ask about persisting the count in the database, it says no, the suggested change does not already exist, but there is a counter here, blah, blah, blah. And here is the new thing. So it writes a short article on how to implement count persistence with Firebase, like generically. It doesn't even take into account React here. So it writes that guide, and the challenging thing here is that these LLMs, they're trained on a shit ton of dependencies already, right? But they're trained on dependencies over a long period of time with different versions, most likely breaking changes. Like Firebase has completely changed their API. So how much of this article is from the usage examples generated from the type definitions and how much is from its training data? Like, impossible to say, right? But it does prioritize the usage examples because that's from the retrieval, right? So there's probably some level of hallucination from like an old version of Firebase here, or there's at least a risk of that. But we do have a real source of truth for Firebase, which is generated from the type definitions and the README. So here it just, like, it created an article. And again, you can imagine this would be a helpful tool for anyone. Like, what if you could go to a website and you just have like, you can check some dependencies and then how would I implement count persistence here? And then it would actually generate a guide for you. Anyways, so that's the new thing. And then we can take a quick look at the implementation. Let's see. So it did this. Oh, sorry. So it created this Firebase config thing where it imports. Of course, it doesn't have the actual config, but that's fine. It exports the app and the database. We can look at the API. Here it imports the database. It imports the different things. It even used like a transaction here to increment the count. That's pretty good. And then in the app file, we can see that it actually imported the right things. So this is like, this is really impressive. But the point is that we didn't make, this wasn't because ChatGPT got smarter. Like, it wasn't because we jumped to GPT-5 that it was able to do this. It was because of the retrieval it was able to do this. So that's what I kind of wanted you to take away from this, is like, how does good retrieval affect the capability of the LLM to actually achieve ambiguous tasks? And then I had this final point. What was that? Yes, so my final point, sorry, was that one thing is, if you create an agent that just has a bunch of function calling, so it goes and it navigates the code base and everything, it's much harder to debug why did it choose to do that instead of that. While when you have retrieval, you can just read the context, right? You can read the retrieved context and you can reason about, do we actually have enough context here to reason about an accepted outcome? That's quite easy to do. And then the question becomes, what if it didn't do that? Like, why wasn't it able to do it? And then it's more intuitive to think, well, it has a limited context window. How much context did we actually retrieve here? Was there a risk that we bled out of the context window, for example? Or if that wasn't the case, well, it's very likely that the LLM just isn't good enough to reason about the context yet. And so on and so on. So I think treating these agents as new engineers in the team that can, like, the goal is to think of them as a new engineer in the team, but they're able to perform as an engineer that's been there for a long time. And they do that because they have incredibly efficient retrieval. Because all engineers depend on retrieval. It's just that as humans, we're really bad at retrieval. We're good at intuition, but we're bad at retrieval. Agents are bad at intuition, but really good at retrieval. Yes. And if I didn't mention it, I'm using Llama Index here for the retrieval. So that's also worth mentioning. Okay, anyways, thanks for listening. And I hope it was inspirational, educational, or confirming to some extent. Thanks.